Hydrolysis. Definition. Hydrolysis usually means the cleavage of chemical bonds by the addition of water, where a carbohydrate is broken into its component sugar molecules by hydrolysis. This is termed saccharization. Generally, hydrolysis or saccharization is a step in the degradation of a substance.
Since molecules can be joined together in dehydration reactions which remove water, these same molecules can then be split apart when water is returned in a hydrolysis reaction. If a water molecule is added to a disaccharide, an OH to one of the subunits and H to the other, then this disaccharide is then split into its separate monosaccharide components. Hydrolysis reactions can also split dipeptides. An OH is added to one of the amino acids and H to the other, and this separates the dipeptide into its separate amino acid components. Three separate hydrolysis reactions can split a triglyceride into glycerol and three
Types. Usually, hydrolysis is a chemical process in which a molecule of water is added to a substance. Sometimes, this addition causes both substances and water molecules to split into two parts. In such reactions, one fragment of the charged molecule or parent molecule gains a hydrogen ion. Salt. A common kind of hydrolysis occurs when a salt of weak acid or weak base or both is dissolved in water. Water spontaneously ionizes into hydroxyl anions and hydrogen cations. The salt, too, dissociates into its constituent anions and cations. For example, sodium acetate dissociates in water into sodium and acetate ions. Sodium ions react very little with the hydroxyl ions, whereas the acetate ions combine with hydrogen ions to produce acetic acid. In each case, the net result is a relative excess of hydroxyl ions, giving a basic solution.
From the world's smallest lab again, here is a saltwater and carbon rod, 0.925 amps watts, give or take. And this is the kind of activity you will see a saltwater cell. Notice that most of the activity is from the negative electrode, very little activity on the positive electrode, which I believe is the oxygen. The negative's hydrogen, positive oxygen. Anyway, this is K4ZEP, and I'm clear.
Esters and amides. Acid-base catalase hydrolysis are very common. One example is the hydrolysis of amines of esters. The hydrolysis occurs when the nucleophile, a nucleoseeking agent, water or hydroxyl ion, attacks the carbon on carbonyl group of the ester or amine. In an aqueous base, hydroxyl ions are better nucleophiles than polar molecules such as water. In acids, the carbonyl group becomes protonated and this leads to a much easier nucleophilic attack. The products for both hydrolyses are compounds with carboxylic acid groups.
Hi guys, welcome to this short and snappy video on the hydrolysis of amides and esters. So first of all, let's begin with amides. So an amide can be hydrolyzed in two ways, either by heating it with dilute acid or heating it with dilute alkali. The products, okay, that's generally true, but that's what happens in this reaction, and that's how I remember it. Find your own way of doing it if you want, or go on. And ammonia gas. The way I remember that is ammonia is a base.